Solutions to problems.
You're one of those ASB chairmen, right? Yeah, you're supposed to handle that. Oh, what are you? I think I have it. I'll answer that. You what?
You're from local parliament.
This looks good on my yeah. No, I gotta, yeah, we have a meeting. Yeah. The email Chris is for, oh, really? I'm not in the group chat. Yeah. I can add you to the group. Okay. Yeah. Not worth it. I can't believe, no, I can't believe. I know, I paid my dues. Yeah, I can add you. Yeah, it's $5. That's what it's It's not. Things like when you can get an HP.
Okay, so this is 16.5 on velocity analysis. Okay, so AB is a link. We're talking about rigid bodies now. So the dimensions of the system we're considering matters. So imagine AB is the link, and the link is rotating at certain speed, angular speed omega AB. We can find a relation between the velocity of a point on the rigid body, it's called that B, and related to the velocity of another point in the body, it's called that A. The relation between the velocities is given by the formula I just put down in the box, this one. So velocity of B is velocity of A, and when I say velocity of B and A, it is velocity of those points with respect to the origin O, so absolute velocity, plus the relative velocity of B with respect to A, and that's always integrated by B slash A. Okay, what is B slash A? It is angular speed as a vector. So, for example, if the body is, actually I should put this counterclockwise. So counterclockwise is positive, clockwise negative. So, for example, in this case, counterclockwise, if you curl your fingers along the direction of the arrow, your thumb gives the direction of the vector. In this case, it's pointing in the k direction or the z direction. So you need to take that vector and cross it with, that's the cross product. Cross it with the vector from A to B. The notation for the vector from A to B is R B slash A. I've seen that students get confused with this. It's from A to B, not from B to A. And that is important because if you switch the direction, like the arrow points from A to B from B to A, then your answers will differ by a sign. It can have a substantial effect on your final answer if you do not have the right direction of the vector. Okay, so we'll see how this formula can be used to solve for velocities of, or angular velocities of a mechanism. A mechanism consists of multiple links that are joined together either by a pin joint or some other type of joint. We're only looking at pin joints. Okay. So what I'm going to show you, this is kind of important because in the past we have always asked questions from this in the term exams as well as in the final. Okay, the next three sections, today's class, Friday's class, and Monday, are three things we've typically asked questions on in the finals and the term exam. So you can expect to have questions on this. Okay, so how do we use this formula to solve for velocities of mechanisms? So here is one mechanism. It consists of a rod shown in brown connected to two rollers A and B, and clearly when this mechanism let loose, B is going to slide down, A is going to move to the right. So let's see what the question says. If the roller A moves to the right with a constant velocity of 3 meters per second, determine the angular velocity of the link, which is omega AB, and the velocity of the roller at B. When the angle theta is 30 degrees. Okay, so there are two things asked. We need to find the velocity of point B and angular velocity of the link AB. So what I'll do is I'll start off drawing a coordinate frame. So in this case, let's say that the coordinate frame is like so, ij. And I'm just going to assume that the velocity of B is upwards. And the reason I'm doing that is because my convention is positive is upwards. Instead of taking the downward direction, writing minus VB, I'm just better off writing VB, showing it upwards and putting a positive sign. So let's try to relate the velocities of points whose value is known. So we know velocity of A. Okay, we need to write a vector for A because we're dealing with vectors. So we know that A is moving at 3 meters per second and it's in the direction I. So 3I is the velocity of A. Velocity of B, well, is unknown. We do not know the magnitude of the velocity, but we do know that the velocity of B is in the J direction. Okay, if I'd assumed it to be downwards, I would just put minus VBJ, but I can put it as VBJ, and then the math will actually tell me that it is actually negative because our intuition says when A goes to the right, B is going to move down. So we start off with positive VB and then solve it and see if we get the negative sign, and I'm sure you'll get it because that's what comes from intuition. Okay, and then finally, I'm going to assume that angular velocity of AB is counterclockwise. So if I curl my fingers along omega AB, positive direction, the thumb gives the direction of the vector. So omega AB, the magnitude, which is unknown, times K. Okay, so let's write the formula relating B and A. The same formula I put down earlier. Velocity of B is velocity of A plus omega AB crossed with RB with respect to A. Okay, let's sub in the values. VB is VB times J equals VA is 3I plus omega AB k crossed with, well, what's B slash A? It is the vector from A to B, this vector. So when I try to write that vector, there's a length involved. The length of AB is 1.5 times the unit vector in the direction, in this direction. So the unit vector in that direction is going to be, I resolve that vector in the x direction, so cosine theta is the, well, that's the component in the x direction, but you can see that that vector, when you resolve it in the x direction, it points in the negative I direction, right? If you resolve that vector this way, it's negative I. So I'll put a negative cosine 30, and then component in the y direction is sine 30 along j, but that vector points upwards, so it's positive. Okay, now let's try to expand the cross product. So VBJ equals 3i plus 1.5 omega AB. Cosine 30 is, I think it's 0.866. Then I have k cross I plus sine 30 is 0.5, and then k cross j. Okay, so I need to do the cross product. Do you guys remember how to take a cross product? What's k cross I? So k cross I is j, and the way I do this is, see if this, so there's multiple ways of remembering how to find k cross I. This is just my preferred way of doing it. I draw a circle, I put I, j, k, so that when I go from I to j, from j to k, I'm going counterclockwise direction because counterclockwise is positive. And then I try to find what is k cross I. To go from k to I need to go from k to I in the counterclockwise direction. So it's going to be j with a positive sign, because in going from k to I go counterclockwise. Similarly, if I want to find k cross j, so going from k to j, I need to go clockwise. If I have to go clockwise, I always put a negative sign. So this will be okay, it's been negative I. So k cross I should always be j, but the sign comes from going from clockwise or counterclockwise in that figure. So that is the second term. And so I'm going to sort of try to club in terms involving I, club in the terms involving j, and then I'll equate the two sides. So let's do that. VB j equals 3i minus 1.5 times 0.5 is 0.75 omega AB, and this negative sign comes out there. And then the j component is going to be 1.5 times 0.66, that is 1 minus 1.3 omega AB. Sorry, I forgot to put an I. We don't think. Let me pull that I out. 3, and then negative 1.3 omega AB j. Okay, I just clubbed in all terms which have an I, all terms involving j on the right side. And now if the two sides are equal, then I should have VB equals minus 1.3 omega AB, and 0 equals 3 minus 0.75 omega AB. The first term comes because I equated the j components. And the second expression comes because I equated the I component. The left hand side has 0 on the I. So if I take these two equations, two unknowns, I can solve for the unknowns. We get omega AB equals 4 and VB equals minus 5.2. The minus indicates that my assumed direction was wrong. It's not upward, but it's downwards, which makes sense because if you move the point A to the right, B is going to move down.
What are the units for omega AB?
It's meters per second and radians per second. Is that clear? So find 2 points, find how they're related using the relative velocity formula, put in the values, and then equate the two sides. Any questions on this? So let's do a harder problem. Extend this to mechanisms. This is a type of a problem which is a good candidate to be in the exam. Something like this. So if the block C is moving downwards with a speed of 4 feet per second, determine the angular velocity of AB at the instant shown. So only omega AB is the unknown. So this is a case when there is not one link like the previous problem, but there are two links. There's AB and there's BC. And we can use the formula on either of those links. Okay, so velocity of this point is given. We know velocity of C. And this problem actually did not have a coordinate frame defined, so I just defined it I along the horizontal and J in the vertical. And that's important. Unless you do that, you cannot write expressions for the velocity. So VC is, well, it's downwards, so it's in the negative J direction. So I would write minus for J for the velocity of C. Is there any other point whose velocity is known? Is 0. A does not move, so velocity of A is 0. Okay, omega AB is the unknown. So I'm going to assume, well, it's given to be clockwise here, as you can see. So if you were to stick to that convention that is clockwise, then I would need to put minus omega AB k, right? Because it's clockwise. Okay, so let's try to see if we can write a formula for velocity of B. We know the velocity of A, but we do not know the velocity of B. So velocity of B is velocity of A plus omega AB crossed with the vector from A to B. But velocity of A is 0, so velocity of B is equal to minus omega AB k crossed with the vector from B slash A is the vector from A to B. So we can see that the vector is shown by the arrow. It's going to be along the I direction. So magnitude is 2, direction is I, so 2I. So velocity of B is going to be, if you want to find ij, the cross product, again I draw I, j, k in the counterclockwise sense, k cross I. If I want to go from k to I, that's going to be j obviously, but with the positive sign because I go from k to I in the counterclockwise direction. So negative 2 omega a b j. Now the thing is, I need to find omega ab, but I do not know vb. So this by itself cannot be used to solve for omega ab. But I do know something about the point C. I know the velocity of point C. So can I write a formula relating velocity of C and velocity of B? That would be my best guess to try to solve for omega AB. So I'm going to write the same relative velocity formula, but now from C to B. So velocity of C is velocity of B plus omega BC crossed with the vector from B to C, or C slash B. Okay, so let's sub in. Velocity of C is known, it's negative 4j. Velocity of B I just found out, it's minus 2 omega abj. And then omega bc is unknown, so let's assume omega bc is counterclockwise. Again, I'm just assuming that may not be the case, but the math will give me the right sign. So omega bc, so plus omega bck crossed with the vector from B to C. So the vector from B to C is shown in the direction which is going at 30 degrees up to the, so it's a vector from B to C, so it's oriented as shown. The length of the vector is 3. If I want to find the x component, that's going to be cosine 30 with the positive sign because it's pointing in that direction, which is in the first quadrant, plus sine 30 j. Okay, so let's simplify this. Minus 4j equals minus 2 omega ab j plus 3 omega bc. Okay, then I need to do k cross I. So k cross I, again the same. I need to go from k to I in the counterclockwise direction, so it's going to be positive j. So cosine 30 is 0.866, and then k cross I is j. Then I have k cross j. So from going from k to j, I go clockwise, so it will be negative I for k cross j. So k cross j is negative I, and sine 30 is 0.5. Okay, so let's simplify this. Minus 4j equals minus 2 omega ab j plus 2.6 omega bcj minus 1.5 omega bci. So equate the I and the j components. Minus 4 equals minus 2 omega ab plus 2.6 omega bc is the first equation equating the j component. And then if I equate the I component, I have 0 on the left hand side equals minus 1.5 omega bc. So that's two equations in two unknowns. It's obvious that omega bc is 0. If you put omega bc 0 in the first equation, you get omega ab. Omega ab is 2. No, positive 2. Okay, so as you can see, it was not very straightforward. It was not using the formula once but twice, which gave me the answer. So I used it once over here and the second time here. In general, if you see if I was given the information over here and here, this was the intermediate point, point B, and so I was trying to find how I can relate C to B and B to A, and in that way I could relate C to A, and that's how I could solve the problem. And all the problems in this section have this flavor. Okay, pretty much they will change. Geometry will change, but it's the same recipe. If you practice these types of problems, this is a sure shot question in the exam.
So in general, the number of links equals the number of times you must have particle to get it.
That's generally true, yes.
Okay.
And we normally restrict ourselves to just 2 links because otherwise the math becomes too hard.
Okay.
Maybe max 3, won't be more than. This is actually considered to be a 3-link mechanism. The third link is the slider.
Okay.
It's called a 4-bar linkage, if you want to know more about it. It's used in a car engine, one of the inversion of this. Any questions on this? Okay, let's see if you can apply what I just did on this problem. If the crank OA rotates with an angular velocity of 12 radians per second, determine the velocity of the piston B and the angular velocity of the rod AB at the instance shown. Okay, so since you cannot poll both answers, what I would like you to do is only poll the answer for VB, just the magnitude. So the question asks you to find 2 things, omega AB and VB, but I only want you to poll the magnitude of velocity of B. And the way you do this is, well, you know the velocity of O, that's 0. First find the velocity of A. Write that down. Velocity of A is 12k crossed with R A with respect to O, so that's going to be 12k crossed with 0.3, and I'm going to assume that this is I, J is upwards, and so J. So find that, and then once you do that, velocity of B is velocity of A plus omega AB crossed with R B with respect to A. So first find velocity of A, put that here. Write these vectors, omega AB is unknown. You know the vector from A to B, and solve for B. And solve the problem, and you can update your answers later on. I think this is slightly involved, so I'll keep it open. So velocity of A is minus 3.6 I plus omega AB is unknown. I'm going to assume it's in the K direction, counterclockwise direction, crossed with the vector from A to B. So the vector from A to B is this way. So the length of the vector is 0.6. And the direction is, well, cosine 30 is the component in the x direction times I, but the vector, the way I've shown it, points in the negative I direction. So negative I, and then sine 30 degrees for j, and that's again in the negative j direction. Okay, velocity of b, we can see that b has to move in the slot up or down. So I'm going to assume it moves up, positive. So vb j. So vb j equals minus 3.6 I plus 0.6 omega AB. So cosine 30 is 0.866. K cross I, as I've shown over here, K cross I is J with a positive sign. And then sine 30 is 0.5. K cross J is, I need to go clockwise to go from K to J. So that's going to be negative I. So this is positive.
Why is cosine theta positive?
Cosine, you mean this thing?
Yeah, because it was going from A to B. And then
Oh, yeah, so you're right. So if it's this way, then the component outside. This should be positive. Good catch. .866 and 0.3. 0.26. 0.26 omega AB J plus 0.3 omega AB I. That's equal to VBJ. So equate both sides, the left and right side, together. So we have VB equals, is that not right? Oh, it should be twice of that. 0.6 times 0.866. 0.52, is that right? Twice of this. So VB equals 0.52 omega AB and 0 equals minus 3.6 plus 0.3 omega AB. So equating the two sides for the two equations, we have omega AB is 12 radians per second and velocity of B is 0.52 times 12. That's 6.24 meters per second. So 6.24 is the answer. If you want, you can update your answer. The poll is still open. Okay, any questions on this? So this is a simple problem. You will not see it's simple because of the geometry. Okay, you might actually see a problem which involves O is slightly tilted, which makes the